Hi, Mark Dingman here from Dolphin Structural Solutions. Late last week, Scout Motors released a video on YouTube revealing the Scout Terra and the Scout Traveler. They didn't focus a lot on structure, but I did put together a video extracting what information I could see or project out of their structure. Imagine my excitement when they retimed the video over the weekend. So I'm updating this one here so that the observation timing of their video matches the images that I'm talking about. Here we go. First thing to know is Dolphin Structural Solutions is my gateway for automotive structure consulting in the industry. So if you're interested to know my background or what I can do, head on over to dolphinus.co. I'm going to run this the same way as I've run other observation videos because I can't use the images that they have in their video. You're going to need to load up the Scout Motor video. You can do that one of two ways in YouTube. First one is go to the search dialog box in YouTube and type in Scout Motors Reveal Event. Or go to the Scout Motors channel, and under the Live tab, you will find this video, Scout Motors Reveal Event. Load this video up into a separate browser, because usually what I'm going to be doing is talking about an image that I see at a particular time step of the video. So you can go to that time step and you'll see the picture that I'm talking about. First thing to note, perhaps it's just a curiosity, is there is some lineage between the engineering team that did the structure on the Scout and the Rivian. And you will see some of those people came from Ford as well. So you will see some engineering solution similarities particularly between the Rivian and the Scout, that have to do with that personnel lineage. So I think the first thing we can extract from this video with regards to structure is the configuration of the vehicle. They describe the Terra and the Traveler as a body and frame. And looking at the images, I tend to like the 3807 image a little bit better, 38 minutes, 7 seconds. You can see that there are distinctly some interface provisions on the frame for cab mounting, C4 per side here. The geometry that we see there for these attachment provisions lead me to believe that this is an isolated body on frame configuration, meaning that you have a frame and you have a cab, and in between those two there's an elastomeric mount. This is a typical configuration, typical construction of a body on frame. Pretty much everything out there has this condition. Silverado, F-150, Ram all have a cab and essentially a rubber element between that and the frame. What's interesting, I think, here is if you do consider that the Rivian R1 architecture is somehow a lineage of the Scout, the Rivian R1 architecture did not do this. They have a body-on-frame construction. They have a frame and they have a body, but there's no rubber mount between the two. They hard mount these, bolt them together with no isolation whatsoever between the two. So here, Scout chose to put some isolation between the frame and the body. There are reasons you would want to do that. I'm not going to get into it here, but just interesting to see that they did seem to choose an isolated route for this configuration. So another interesting thing with regards to configuration is that it appears that the Terra has an integrated pickup box structure. Now, what do I mean by that? The structure of the pickup box is unified and integrated to the cab structure. It's one structure, as shown in this sketch here. This is as opposed to, let's say, what is historically traditional or historically conventional for an isolated body-on-frame configuration, where the pickup box and the cab are independent structures. They mount to the frame independently through their own isolators and thus are allowed to vibrate independently as well. The image we see at 38 minutes, 7 seconds, I think is a clue for the answer here. If the Terra were a non-isolated configuration, we should see two sets of mounting locations on the frame here. One for the front of the box and one for the rear of the cab. But we only see one in this location, leading me to believe that this is an integrated solution. So the video sequence at 21 minutes, 4 seconds is a little bit of a head scratcher with regards to integrated pickup box structure. The video starts at the bottom of the car, showing that the pickup box and the cab are integrated at the rocker, way down low. At the end of the video sequence, we see that the grab handle coming off of the pickup box is connected to the cab, suggesting that they're integrated structure. But in between, we see glimpses of a deep channel between the cab and the pickup box, giving the impression that this is a traditional pickup where the two structures are separate. I think what's going on here is that the quarter panel or the pickup box side is what we would call an applied panel. We can unbolt this from the structure, or in the manufacturing process, it gets bolted onto the structure. If we see the C-pillar as it wraps around to the back glass, there's a chamfer to it. This is a kind of a top view. Front of cars over on the right. As the chamfer comes around towards the back glass, I believe, and guessing here, that the true structure of the pickup box is integrated and joined at the inboard location of this chamfer. Everything else we see to the outside of that is what we would again call an applied structure. Now, going a little bit further on the idea of an applied panel here. So notice that both of the vehicles shown in the reveal event have black A-pillars and black roof rails, regardless of the color of the car. Now, all Scouts ever made have black A-pillars and black roof rails, and they figured out how to do an applied panel configuration for the Traveler variant. The Scout's in a condition where they could run these vehicles through the manufacturing process like an old Saturn or like a Cybertruck is. Now, what do I mean by that? Conventionally speaking, vehicles constructed, the structures made in body shop, including the quarter panel on the roof that need to get painted. Structures made in body shop progresses to paint shop where it's cleaned, it's primered, and it's painted. If the customer wants a white car, it's painted white in paint shop. If a customer wants a green car, it's painted green in paint shop. Then that goes to general assembly or final assembly, and everything else gets put on the car. With an old Saturn or a Cybertruck, similar, the structure's made in body shop, progresses to paint shop. There's again, it's clean and it's primered. But here, every single one of those structures is painted black. Goes to general assembly and final assembly. Everything else gets put on the car, including the panels that have the color that the customer ordered. My picture of my old Saturn here, that quarter panel is bolted on in general assembly, as was the roof. The roof's green here, but that was put on in general assembly. So painting every one of the structures black and painting all of the other panels independently can be considered a complexity reduction and maybe an opportunity for cost save. Again, I'm not sure that's what they're doing. Indications are that they could be doing this. The second thing that an applied rear quarter panel could solve is if you remember back after the Rivian R1T launched and the damage in the repairability of the rear quarter panel, the R1T rear quarter panel was integrated into the rest of the structure. If you got a fender bender and a ding in that quarter panel, you had to replace the whole side of the car to replace the quarter panel. So the costs were high, got a lot of press, and certainly an applied quarter panel would be less expensive to repair, perhaps a learning again from the lineage of the Rivian R1T. So we see the construction of the frame at 38 minutes and 7 seconds. The longitudinal side rails appear to have a clamshell construction, two halves coming together to make those. That's pretty typical in the industry. The interesting thing is the image shows a one-piece upper panel that includes both crossbars, torque boxes, and likely the one bar as well. This is different for sure. I know that part consolidation is a big thing right now with the industry, but this amount of part consolidation would seem to cause some dimensional quality issues, especially if you're trying to connect the vertical surfaces of the crossbar to the longitudinal side rails. So the other thing we see in this image are the troughs that are created by attaching the propulsion battery to the frame. Now, if we're right that this is an isolated body and frame configuration, and the cab and the frame are going to be moving around independently because of the presence of the elastomeric mounts, then sealing the space between the cab and the frame will be very, very difficult. If water and debris can get in between the cab and the frame, then these troughs would seem to have a tendency to capture the water and the debris. I'm believing if we've got everything right here and we're guessing everything correctly, then there's probably some pretty serious water management strategies that Scout has engineered here to get stuff to drain and not settle and stay in this void. So we can look at the same image from the perspective of structural topology. And generally speaking, the structural topology of the frame looks really nice. Structure flows from the one bar to the torque box to the side rail and the crossbars really well without a lot of geometric structural discontinuity. We see tree trunking in the cross members, and tree trunking is when the width of the section increases as it approaches the end of it. And we see that as the crossbar in the Scout approaches the side rail. Now I'm saying that these are likely fine-tuned because tree trunking can have an advantage in load dispersion in some load cases, but it can also cause section instability and buckling in some of those same load cases. So I'm sure they went through this pretty hard to maximize the advantage without hitting one of those issues with structural integrity. A little bit later than the 38-minute 7-second, if you let that play a little bit longer, 38 minutes 9 seconds I think is my favorite one to see. This is most obvious. There's an interface pocket in the rear torque box of the frame. This is a rather sensitive place to put some kind of structural discontinuity. Sometimes you've got to do it. Oftentimes you've got to do it for the rear suspension, and I believe this is probably for the rear suspension trailing arm. Now, there's another image at 32 minutes 53 seconds that makes it look like there is a spring link, a leaf spring on this car, even though there's a coil over the damper in the same image. It has a geometry of a leaf spring, but it doesn't seem to have the end condition. Anyway, what we see at this 3253 might be some kind of structure to attach skid plates to. I don't know, but whatever is causing the pocket or the need for the pocket at the rear torque box, not a great place to put it. Like I said, oftentimes you've got to do it, and I'm sure they reinforce the heck out of it. So let's talk a little bit about the propulsion battery housing and the propulsion battery itself. In this 38-minute 7-second image, we see the configuration. I believe what I'm seeing here is a propulsion battery that's divided into two distinct sections. Just forward of these longitudinal beads, we see a trough that runs left to right on the battery housing. I believe what we're seeing here is a delineation between cell packaging behind that and power electronics up front. Just a guess. With regards to structural topology, the longitudinal beads here give me the impression or the indication that there could be longitudinal propulsion battery housing structure inside the pack, similar to a Model 3. This does appear like it could be a twist on the Model 3 design and integration. And from a structural integration perspective, the fact that if they're there, that longitudinal structure within the battery stops short of the one bar is a little bit of a handicap. But I can imagine, if all of this is going the way I think it is, that the tree trunking and the integration into the crossbar, the cross member that's right here, could overcome some of the disadvantages of not having that longitudinal structure go all the way forward. Real guess here, I'm really excited to see the inside of this. So when I see new structures, one of the things I like to think about are load cases that are particularly difficult to engineer for. And one of those is the IIHS SOF, and that's the Insurance Institute for Highway Safety Small Overlap Frontal Crash Test. Now, we're not shown a complete picture of Scout's crash worthiness strategy for this load case. We don't see the body structure. We don't see the front chassis. But there's a few things I think are interesting to pull out. The image at 38 minutes and 8 seconds, the front wheel crosscar position relative to the frame side rail, the wheel appears to be fairly well outboard. That's advantageous for a particular crash mode that most manufacturers try to go after. The same image there at 3808, the front torque box topology is highly chamfered, like the R1X, but also like a lot of other vehicles out there. There's a good reason to do that, but we see it here, and again, that's good. Slightly before that, the 38 minutes 07, I'm not sure if I'm seeing what I'm seeing here, but it appears that we see the lower control arm of the front suspension in this image. And if I'm seeing that, it looks like it's a rear-facing lower control arm configuration. Now again, assuming that Scout is going after a particular crash mode or crash mode for IHS SOF, a rear-facing lower control arm has an advantage over a forward-facing lower control arm. We see a forward-facing lower control arm in the Rivian R1X. So again, we might see some a lineage design progression from that architecture, from that team's learning. So wrapping this up, we weren't shown a lot specifically around structure, but I think there's a few speculative things we were able to pull from the video. In summary, two things. I think there's an indication of a design refinement over the R1X platform. Again, you can consider the R1X platform as some level of design lineage of the Scout vehicle, or simply a vehicle that they benchmarked during the development of their car. Also indications of advancement in battery electric vehicle structural topology and integration. Both of these things are good, and I think about from the big picture perspective, both of these things offer opportunities for lower cost for the vehicle, which is important in the EV world. So thanks for hanging in there, and I look forward to seeing more of this just like you, I bet. Take care.